Hello everyone. How would you differentiate between a PAC, a PJC, and a PVC? Go ahead and pause the video and think about the answer. So normally in the heart you have the SA node cause atrial depolarization. So that would be the SA node. Then the impulse passes through the AV node into the ventricles. So you have the AV node, and then this goes on to the ventricles. So in essence, that's how it goes. So let's go ahead and map out a few more impulses. Now notice that the intervals between the P waves is relatively constant, and the P waves all look similar. So that's my best attempt at drawing something that's similar. Now, something might happen in the atria. There might be another irritable focus that fires off before it's supposed to fire. So you would have a weird looking P wave. So let's go ahead and draw it like that. And notice that it happens before you would expect the next wave. Now, at this point, a few things can happen. So it can pass through the AV node and then get conducted normally to the ventricle, in which case you would have a QRS complex that looks okay. So let's say that's an okay QRS complex. The other option is it might go through the atrium but not the ventricle, in which case you would see a P wave and then nothing. And the third option, so in the first wave also you would see a P wave. And the third thing is, what could happen is that because the beat's happening so quickly, a part of the ventricle has recovered from the prior beat, but a part of the ventricle hasn't. So in the heart, you have the SA node, the AV node, and then the bundle of His, the right bundle and the left bundle branch. So let's assume, because the last beat was pretty early, while this part of the ventricular conduction system has reset, this part, so the right bundle, has not reset. So now when a PAC happens, the impulse goes from the aberrant focus through the AV node, and because the right bundle is not active, it would flow through the left bundle and then depolarize both the ventricles. In other words, because the right bundle isn't conducting the way it should, you might see a QRS that looks something like that. Now, following the beat, because the atria has already gotten depolarized, this would go ahead and reset the SA node. And so a normal P wave wouldn't appear where it's supposed to appear, but instead it would be slightly later. So let's say about here or so. Now, one thing that's usually true of PACs, when you look at the RR interval between the two beats, this is usually less than 2 times the normal RR interval. So in other words, there is a pause happening here, but then the total duration is less than 2 times the normal RR interval, and this is the normal RR interval. And so this would be incomplete compensatory pause. So when you're thinking about a PAC, notice that the shape of the P wave is different. Because it's coming out of a different space, the PR duration may be different, and you could have either a normal QRS, no QRS, or an abnormal looking QRS. But then there is a preceding P wave. Now, sometimes what might happen is that the P wave might be hidden inside the preceding P wave and change the shape of the T wave. So this would be something that you would want to keep an eye out for. Now, because the P wave is starting off in the atrium, it would still have to go through the AV node, and so typically the PR interval is more than or equal to 0.12 seconds. Now, another thing that might happen is that you could have a P wave conducted through the AV node, a QRS, a P wave conducted through the AV node, a QRS, and then something near the AV node kind of gives off an impulse. So the impulse is starting near the AV node, and then it gets conducted through the AV node into the ventricle, and sometimes it could go back as well. So if this is the case, the QRS that you see could be one of the three scenarios in the PAC. So it could be a normally conducted QRS, which is normally the case, or you might not see the QRS if the junctional beat is happening too early, or you might see it at a point when a part of the ventricle is still refractory, in which case you would see a bizarre looking QRS. You might also see a compensatory pause that's incomplete. But one thing you would notice is based on the origin from the AV node. So if it's coming from high above or close to like the upper part of the AV node, you would notice that there is a P wave, usually inverted, immediately before the QRS. So it might look something like that. If it's coming from somewhere in the middle, you might just see a flat line with a QRS. So the P wave is embedded within the QRS. And if it's in the lower part, you might see that the QRS actually shows up, and then you might see a P wave hidden after the QRS complex. So when we're thinking of a junctional rhythm, always look for a P wave immediately before or after the QRS, or sometimes it might be hidden in the QRS. So in this case, the PR interval would be less than 0.12 seconds. Now let's consider the third scenario. You have the SA node sending out the impulse to the AV node, and from here it goes to the ventricles. Now, normally, an impulse starts off in the SA node and travels down this pathway and then very quickly depolarizes both the ventricles. Sometimes you may have a focus in the ventricle that starts off an impulse when it's not supposed to. So, in other words, you have the P going through the AV node and then the QRS. You have the P going through the AV node and then the QRS. But then at this point, something happens in the ventricle. Because the impulse isn't following through the most efficient pathway, the waves of depolarization spread haphazardly, and so you would have a weird looking QRS. So let's say it looks something like that. So you have the wave spreading back, and then it kind of stops at the AV node. And if this is the case, the next P wave might not necessarily be able to cause a ventricular contraction, but the P wave after that would pass through the AV node and cause a normal QRS to happen. So if this were the case, then the RR interval here would be equal to 2 times the normal RR interval. And this is because the impulse from here didn't really go all the way back and reset the SA node. So in essence, the next beat happened as predicted, and so you would see that the RR interval is twice the normal RR interval. So this would be the normal RR interval. So in other words, this would be a complete compensatory pause. Now, one thing we've talked about in the past is that usually the QRS and T waves are in the same direction. However, when a beat originates from the ventricle, one thing to keep in mind is that if the deflection of the QRS is upwards, then the ST segment may be depressed and the T waves may be inverted. So, in other words, the QRS complex and what follows it are discordant. So, QRS and STT are discordant, meaning they go in opposite directions. Another thing to notice is that the QRS morphology is pretty messed up and they are wide. So you have a bizarre QRS that's wide. This would be a normal P wave, a normal P wave, and a normal P wave. And notice this bizarre looking P wave. This would be a PAC. And also notice that it's actually happening earlier than expected. So this one is longer than this one. So the beat's actually happening earlier than expected. And one last thing to notice how the RR interval is also longer than you would expect it to be. Now in the strip below, notice the P wave, the P wave, the P wave, and the T waves have a certain morphology. And here you see this long pause, and notice that there is no clear P wave, but then the T wave looks different compared to the T wave here. So essentially the P wave is hidden within the T wave. So this would be another example of a PAC. Now in this strip, notice the P waves which look okay, and then you see this bizarre looking P wave. And you can notice that there is aberrant conduction. So this would be an example of a PAC with aberrant conduction. Now in this example, we can see that there is the P wave, the P wave, the P wave, and then you have a QRS but no P wave. And the same thing is true with this beat. So the hidden P wave is probably within the QRS. From this EKG, it appears that these beats, because they're appearing sooner than expected, would be premature junctional contractions. Now, if for some reason the sinus node doesn't work and you see a long pause followed by a beat, then it's essentially happening because the normal SA node isn't working, and such a beat would be considered an escape beat. And if it's arising from the atrium, it would be the atrial escape beat. From the junction, it would be a junctional escape beat. And if it's from the ventricle, it would be a ventricular escape beat. In all three scenarios, the beat appears later than you would expect it, unlike here, where you can notice that it's happening sooner than you would expect it. Now, notice in this case, this bizarre looking QRS complex with no clear preceding P wave. And also notice that when you measure the RR interval from here to here, it's half of the RR interval between these two beats. So essentially this is a complete compensatory pause. And this would be a PVC. Now here you can see a P wave followed by a QRS. And then notice these bizarre looking QRS complexes with no preceding P waves. Again, you have two normal QRSs with preceding P waves, and then you have two bizarre-looking QRS complexes. So these would be examples of couplets, ventricular couplets. And this would be another example for PVCs. Now, in this rhythm, notice how you have a P wave followed by a normal QRS, and then you have a PVC. There's no prior P wave. The waves are discordant, meaning the QRS and the ST waves are discordant. And again, you have a P wave with a normal QRS and a PVC, a P wave with a normal QRS and a PVC. And this alternating rhythm is called bigeminy, ventricular bigeminy. Now let's take a look at this strip. You see a P wave followed by a QRS, a P wave followed by a QRS, and then you see these four random looking beats. And notice how they're broad and there is no preceding P wave, so these beats are likely of ventricular origin. So the convention we follow is that if you see less than 3 beats, these would be PVCs. And if you see 3 or more beats, it would be considered ventricular tachycardia. Now, if it's less than or equal to 30 seconds in duration, it would be considered non-sustained ventricular tachycardia. And if it's lasting more than 30 seconds, it would be considered sustained ventricular tachycardia. So, to paraphrase everything, when we look at these funny looking beats, ask yourself if they're happening earlier than expected or later than expected. If they're happening early, that would be a premature contraction. And if it's happening later, it would be considered an escape beat. Now, if you notice that there is a P wave and the PR interval is more than 120 milliseconds, the beat is likely originating from the atrium. On the other hand, if the PR interval is less than 120 milliseconds, or the P wave is embedded within the QRS, or the P wave immediately follows the QRS, it is likely that it's a junctional beat. And lastly, if you see a weird looking QRS complex, with no relation to a P wave, it's likely a ventricular beat. I would like to take a moment to thank Life in the Fast Lane for allowing me to use their EKGs. And as always, thank you for watching.